Hello, hello, testing, testing, 1, 2, 3. Can everyone hear me in the stream? Am I loud and clear? Testing, testing. I want to make sure if the sound is working correctly. Okay, nice to hear. I'll be back. Okay, this is LameGuy64 and welcome to my DTL-H2000 programming stream, where I'll basically do whatever I want to do on this computer, which is running Windows 98, as you can see, with DTL-H2000 development board. And I'm gonna be I'll be continuing work on Project Scarlet. Okay, so I'm gonna continue working on some custom assembly routines that I was starting a while ago, and wait, just a few problems. And it's already solved. So okay, so I'll be doing some assembly work for now. I'm gonna finish this triangle subdiv routine today. First, I'm gonna I'm gonna show you what the routine looks like now after I reset this clip function here, so that it'll clip the polygons off properly, because I'm planning to add the polygon clipping later. So okay, it's already compiled and PS1's already reset. So this is the actual SN debugger debug environment. From my experience, Xbox programming is a bit difficult, Clancy. Mainly because it's hard to get a hold of the XDK, and it's hard to get it to work, or it's just tricky. Mainly because there's very few documentation about it. Probably even fewer than the PS1. So let's run this program and see if it runs. Of course it does. On the lower right corner, it's the output of the DTL-H2000. So right now I have the subdiv routine display a wireframe of triangle. When it's not being subdivided, it's a film, but when it gets subdivided, it becomes wires. If you look closely, you can see that as the polygons get bigger, the triangles get bigger, they get subdivided further, and that's the whole point of this function. As you can see, so that because the problem with the PS1 when it does 3D graphics is the GPU is actually 2D. It's actually not a 3D graphics processor. It's just a GPU that draws 2D triangles. And then the problem, if you draw textured polygons that way, it'll look all distorted because of affine distortion instead of perspective correct texture mapping. Now all the 3D is actually done on the CPU side, so that's why this kind of subdivision is essential to making nice perspective correct polygons on the PS1, or at least close. It's much more easier to see on the white white triangles. So what I'm gonna do is that I'm gonna make these generate filled triangles instead of wireframe triangles by changing a few things in the code. And then I'm gonna add a screen clip routine so that the triangles that are off screen will not be drawn, to save up some cycles and packet space. I'm not sure, it depends. The PS1 is actually fairly easy to program for once you get the hang of the platform. If you're happy with assembly, you can try programming for the Genesis. 68,000 assembly, by the looks of it, from my experience, it actually doesn't look too bad. At least it's not x86, that's for sure. Man, x86 programming is really a pain. I actually tried programming some assembler routines in MIPS, in x86 on my 386, and it was a pain. No joke. And then also the routine dies when working with large sprites. Also, there seems to be some contact problem with my joystick. Give me a sec. So, yeah, I'm gonna change a few values to make this output filled polygon triangles instead of wireframes. I'll reset this so that I quickly go back here and I'll go back there. So what I'm gonna do is I'm gonna go delete some dead code here, unneeded code here. It's just this one here. This is part of an old logic that's not in use anymore. So yeah, this is all MIPS assembly, and let's see if it'll still compile properly. Well, I just wanted to give PS1 a shot, and finding the SDK for it was not too difficult. And also, when I was little, I wanted to make my own PS1 games, and I wanted to have a go at PS1 programming. I have been in a while before I started working on Marilyn, and a 2D platformer game. Which, by the way, the character in that game is not owned by me. It's owned by Nerdsman567 on DeviantArt. So what we need to change is we need to remove this. It's supposed to be. I don't think it should be prim. It should be prim sort L. So we need to. I'm a bit confused. Yeah, okay. So that should do it. Then this one here too. We need to remove this. These are Terminator bytes. This is a Terminator word for the wireframe for the polyline. And then the reason why I got my DTL-H2000 in the first place is that I actually won it from a competition with my Marilyn game back in 2013. So so at that time that was the most impressive homebrew known in the PS1 scene. And the PS1 scene is not very big to begin with, so finding cool stuff like that Marilyn game is such a rarity. Just making sure so that the assembler routine will not crash or corrupt the primitive packet buffers. So this one has I need to remove this and make it like that. I noticed some inconsistencies just now, and I'm surprised it still functions correctly. What setup are you using? Emulator or stock console with a Explorer cartridge with Kytla flashed on it. No cache PSX emulator is not too bad for entry-level PS1 programming, actually. And maybe I haven't tried the Zebra emulator yet. I heard that it has features that it'll be very handy for some testing. Let me see if there's any changes up here. Actually, it's easier to find an Explorer. Those have parallel ports built in. The Game Sharks, they often require that old PS Comlink card, which plugs to an ISA slot, and therefore you cannot use it on a modern computer. Explorer carts, though there was a version, I think the Game Shark Pro has a real parallel port, but generally you may want to go for an Explorer if you can find one. They're easier to work with by the end of the day. I think I could optimize here. When you're optimizing in assembly, you gotta minimize NOP instructions, because on a slow 33.3 megahertz MIPS processor, you'd want every cycle more or less counts. I'm not sure. I haven't checked on eBay how much they usually go for these days. I'm gonna comment this out just to make sure. Okay, compile. Warning, hazardous interaction at line 96. Ah. Yeah, the GS Pro and a few others. I don't know, usually Game Sharks and Action Replays have required to use the PS Comlink card to connect to it. By the way, you can actually use an Explorer or any parallel port cheat cartridge on a modern PC as long as there's a parallel port. I've seen motherboards I've actually seen latest socket AM4 and socket 1151 boards that still have parallel ports on them. Oh yeah, I've heard of super cheaped out flash cartridges, cheat cartridges I meant, where the parallel port for some reason is not wired to anything. Okay, load and execute. Let's see if it's drawing flats now. Okay, it's perfect. Clip behavior is normal. It's a little slow, but I suspect that's because of the The quad subdivider is a bit unoptimized. Why not I have a go at optimizing this triangle subdivider as well? So what you want to do when you optimize is not only would you want to minimize memory access, but you'd also want to minimize instruction length. The length of the program. The smaller the program, the faster. Oh, video is smooth, that's for sure. Yeah. Still in prototype phase. I was working on the triangle subdivider, and eventually I have to make a texture map. I'm gonna also have to rewrite the quad subdividers because they seem to be a bit unoptimized. So I'm gonna go try to do some optimization here for. Let me see what I can do here. So I wanted T0, T1, T2 to be inputs, but not destroy them. Oh, hi Robert. Yeah, still working on it. Still working on this Scarlet Engine project. I'm gonna check a few things. A sec. Okay, I'm back. So what I wanted to do is I also want to minimize the number of JAL jump and link instructions because they are apparently pretty slow. So the problem right now is it does these two calls and it does a second read. So what I want to do is that I read the screen coordinates here because these routines here are for getting the size of the triangle it's to get the size of the triangle pretty much. So for dynamic recursive subdivision, and then that's also how I determine because how the dynamic recursive works is that subdivision is based on the size of the triangle. If it reaches a certain size, it gets subdivided, and then if the subdivisions reach that size again, or it still exceeds it, it will subdivide even further. Many late PS1 games feature that kind of form of subdivision because it looked much more seamless than having whole polygons subdivide. Plus, you can have you don't have to worry about making the polygons have a consistent size to have consistent subdivision. The inconsistency will basically be a bit less apparent. So what I'm gonna do is I want to just make this a single function call. So for compatibility reasons, because there are multiple steps that still use these. I'll just copy this. In assembly, you want nice compact code for speed. Thanks anyway. So I think I could just make this. Let me see if there are any registers it's destroying. V0 is in use. V1 appears to be vacant, so let's use the V1 registers. So T0 16. SLL shift left logical. SRA shift right arithmetic. The reason why I have to do this is because the word inside this register, it contains two 16-bit words, one for the X and Y. So the quickest way to extract the 16-bit word from a 32-bit register is you perform a shift left by 16 and then shift right arithmetic by shift left logical by 16 bits and then shift right arithmetic by 16 bits. Shift right arithmetic is different from shift right logical because shift right arithmetic actually preserves the sign bit. So this is so yeah, it preserves the sign basically. Sign bit being the very last bit of a word. So basically what this does is it does sign extension if the last bit is on, in the case of a negative word, negative signed word. So make this V1, and then for this stage I repeat SLL V1 T1 16 SRA V1 16. With assembly, fiddling with registers is a lot faster than fiddling with memory, since, well, registers are directly attached to the CPU. So that's why you want to keep most of your I have an even better technique here, so I don't have to double. Oops. So I'm gonna wait. Oh yeah, you can still use that same value for this case. Actually, assembler isn't actually too hard to get into as long as you get the as soon as you get the hang of it. You're just basically limited to just a bunch of discrete instructions, and then you use those instructions to do whatever you want, to do the things you want. The thing about assembly is that it's just slow. That's actually the only big difficulty about assembly. It's just slow because you're working with bare instructions. You don't have any high level commands. Pretty much, it's basically just you and the CPU. The benefits of assembly, such as speed, are worthwhile though. So it was very common for developers back in the day in various programs to do the most intensive stuff like graphics routines in assembly, and then the rest in C. Well, I heard some developers even wrote games from entirely in assembly language. Even I can't handle pure assembly programming. It's too much for me. So why is this blanked? V1 T2 16 V1 16 T3 V1. Gotta watch out for syntax errors. Well, we don't have to worry about typos because we can track it down with a debugger. So let me double check, make sure it's all nice and all written nicely. I think it's just still a prototype function, so I'm gonna use that in the first subdiv stage. So get try size, and we don't need to do this anymore. So let's save, assemble, then we go back to the debugger, stop, reboot. I'm likely going to do an art stream after 2 hours. So reload, and then before you run, we have to set a breakpoint at the routine, so in double, so we can ensure that it's functioning correctly. So it's this one here, F5 to set breakpoint, run, and it should stop there. Okay, and then we step and then look at the registers. So what it is doing here is it's taking the X coordinate here. These are two 16-bit words here, X and Y. So what this does is it shifts it right and shifts it left, just in case it's a signed value. So it's basically sign extension. So T3, T4, yeah, that's AT. V1. You can just scroll through and then see. Okay, seems to be working correctly. Now we need to add the pair set for the Y size. I think we just compact things further. We can just copy this. I could do the size check there. Yeah, the H2000 will just display color bars like one you're seeing on the lower right corner. That's what it should display normally. Also make sure you've set the jumper that sets NTSC or PAL mode to the correct setting. Like if you have a PAL TV, use PAL setting, or if you prefer NTSC or have an NTSC set, use NTSC. There are 3 jumpers for that. I know there's a jumper of 3 sets of jumpers for that. Well, you can find the diagrams for making a DTL-H2. When you're making a video cable for your H2000, I recommend just getting a female DB15 connector, the same one used on VGA, and then just use a straight VGA cable. And then just make a sort of a breakout cable, squid cable with that, and then just use a VGA cable to connect to the H2000 board to that breakout connector. That's the method I'm using, and it's much more convenient to deal with. But make sure that the VGA cable that you're using has complete pins. Like all the pins are wired up. I've heard some cheap VGA cables would have some of its pins not wired up. Okay. Welcome. Oops. So after these checks, it'll form if B branch greater than, and if T5 is greater than V0, jump to assembly confusion kicks in. Maybe when I set it to 0. So not. So I could perhaps just copy this for the Y check. Change the labels. By the way, I managed to get CodeWire R5 working. Some chaps at Assembler Games, I don't exactly remember their handles, but some chaps at Assembler Games managed to get the master key out of CodeWire R5's DRM, and I can actually use CodeWire R5 now. And I already have it working on the Windows 2000 installation of my system here. It's actually pretty different from the SN stuff. I'm not sure if there's going to be a performance benefit if you use that over SN's compiler chain. Okay, good night, Nocturnal Donut. How ironic for someone to be called Nocturnal. Oh well. Sweet dreams, mate. So we need to change this here, otherwise it'll become an infinite loop because it's gonna branch up. So we also need to remove this SLL because we're gonna get the right, the Y word, and then do another check here. And then if it doesn't pass, it'll just return a non-zero value. It'll leave V0 alone. If it passes, it'll set V0 to 0, and then that's when it's time to subdivide it because it's exceeding the size of the polygon. If T5 is greater than V0, then let's exceed. So let's go up and do some changes right here. Right over here. So we're gonna remove this. If this, we just need to change this to BEQZ V0. If it becomes 0 after this call, then time to subdivide. So let's see if this assembles. Okay, no errors, so looking good. By the way, how's the stream quality? Is it nice and smooth or is it stuttery? Doesn't look like it's stuttering too much. I just want to make sure. Preview doesn't show like that it's stuttering. So let's reload. Make sure breakpoint is in the correct location. Set it to here and then run. Yeah, okay, nice to hear. Even though this is 29.97. So there isn't much of a point to make this stream 60 FPS. Anyway. T5V0 exceed. T5 is not greater than, so it passes. And it checks the Y. Suspect something wrong is here. Let me check again. Oh man, I forgot to study. Okay, this is the Y checks. Oh man, oh, that's supposed to be normal. For oh, I forgot some SRA instructions. Reboot again. Not sure how to describe, but basically in assembler you're basically greeted with a bunch of processor opcodes, and then your registers are pretty much like variables that are inside the CPU. And on MIPS architecture, what you basically do is when you're doing some arithmetic with a value, you load it from memory with an instruction from a memory address set on a register, and then you do whatever you want with it, and then you can store it back. It's not too difficult actually, but it takes time to get used to. Even I took a while to get the hang of it. Oh yeah, there's something wrong here. It's syntax errors everywhere. So here, this is supposed to be T0. So I was only calculating zeros for the Y side. I think I need to remove some here. Because I see some redundancy. Maybe remove that. What first checks? This is supposed to be T2. T1. The one thing about assembly is that it's actually pretty satisfying once you get the hang of it, and you got a rather complicated routine working entirely. That you've wrote entirely in assembly working properly is pretty satisfying. So it should work properly here now. $22. Okay, we'll let it run away, so let's clear breakpoint and let it go. There we go. And let's see if it works correctly. Hard to tell, but it seems to be working fine. I should have kept the wireframe for a while before I did the change. But it appears to be working, judging by the gaps, the seams that appear. It's actually normal because that's the nature of how the GTE works. It's not very precise, so because the GPU only gets 2D coordinates, and then differing densities causes gaps. If they're even, I don't know, it's hard for me to explain, but basically how developers fix that is that they put like a tiny strip of triangle that fills that up, which fixes it with opaque polygons, but with translucent ones, you'd notice streaks on those. Well, that was the best that you can do. I use assembly for the complicated I use assembly for the intensive routines like polygon subdividers, and then everything else such as collision is done in C. So it's a mixed language setup. Yeah, I'm trying to target 60, but it tends to drop to lower. It doesn't drop to 30 immediately because it has adaptive VSync. So that's why I'm getting like 50, 40, but it's pretty good for the PS1. I'm not sure how well it performs with textured polygons, but most of the bottleneck is, from my experience, is the CPU so far. So I also need to optimize the quad subdivider because I believe it's a lot slower than the triangle one. But yeah, I'm actually running 60 FPS on PS1 hardware. Also, if you haven't watched my stream before, do you notice that the 3D background? I think you haven't caught that yet, but yeah, there's 3D backgrounds on this engine demo. I have not seen any other PS1 game that has a background like that. And if you played A Hat in Time, yeah, that background might look kind of familiar. It's not an exact copy, but it's pretty close, and it looks nice. That's for sure. Okay, I'm gonna go and work on applying this new size calculation routine on everything else. It should be a matter of replacing instructions. Yeah, the thing from my experience, the thing about 3D background is it doesn't look like a pixelated mess. Though there's actually a few PS1 games that feature that style of background, but it's not exactly 3D, but it's kind of close to it. Like for example, in the Spiral games, the background is actually a 3D polygonal dome consisting of Gurod consisting of shaded polygons, and it actually looks really nice. Mine uses a combination of polygons and textures and polygons on different distances. It feels like they're like massive, and they don't move when you move because they're like super far away. So where was I? Oh yeah. So it'll just be a matter of replacing this with that, and then wait, let me see if I've made sure that change up there corresponds to the new one. So BQZ. I haven't really benchmarked, but it should be very little. I'm planning to rewrite my SMD polygon rendering routine because the thing about the 3D background, the renderer for the 3D background is that it does not do any Z sort. So you have to manually pre-sort the primitives first. But the advantage is it's fast and it does not interfere with the main geometry. It should take up very little because there's no backface culling, there's no Z sorting. It should be incredibly fast. It's just blasting the. I think the only thing it really does is just the clipping, discarding polygons that are off screen. But even then, that doesn't take up too much processing power, so it should be very fast. Spyro also uses the same background style, and maybe a few others. The late PS1 games tend to use that more often. Because it's faster and it looks nicer, so it's sort of a win-win. And oh yeah, V0. YouTube is complaining about high bit rate, but that's the recommended rate, 4000 kilobit. Seems to be working fine. Yeah, YouTube. It's not too. It's just a tiny overhead. I exceed. No. Thanks for the compliment, CH. Yeah, I'm one of the rare few active homebrew programmers who has made something 3D. It's a rare thing to see, indeed. Because as far as I'm aware, there's two like 3D homebrew projects going on that I'm aware of. That's this one that I'm working on, and Noah and the Pool Huddles on PSX Dev. And that one was also pretty impressive too. His engine is also a little bit more developed than mine because his has MIP maps and spiral style fading LOD thing. Yeah, I can't even do fading LOD because it takes a lot of processing power. I want to target 60, so better go with a crude method. Though I haven't had very far draw distances working yet. It looks like it's all replaced. So let's compile it. Stop the program, reboot the boards. Reload and execute. Let's see if the program function still works. Also, I think the reason why the values here are changing from time to time is that I'm actually viewing the packet buffer here. I was debugging something packet related before. It gets slow here because there's so many polygons being Z-clipped, There's some clipping problems here too because it disappears I think I know the cause. I think I need to add more cases. I'm gonna fix that when I start optimizing the quad subdivider. Well, I guess that's in. Wait, I'm gonna try to work on adding a clip routine for the triangles. So what I'm gonna do is I'm gonna set the clip window to a smaller value so we can see if the clip is working properly or not. Reason why you want to clip is, why would you want to draw a polygon that's outside the off screen? It's a waste of packet space. Even though the GPU does clipping, it still slows it down a little, and it eats up packet space. Okay, now out on the outer parts, you notice that the polygons disappear. Well, that's because they're being discarded from the clip window. As you can see, it's working on the quads, working on the 3D models, working on the background renderer. You usually don't see that clipping. Also notice those streaks there, that's the filler that hides the gaps in the quad renderer. It didn't clip that for some reason. I'm gonna fix that when I do a rewrite of it. The reason why I didn't bother doing checks on it was because it was slow. It works properly here. It doesn't prematurely clip away here. Anyway, it does. It's strange. I'm gonna fix that later. So the problem right now is the triangle primitives don't clip off. That's why they look like they're being drawn correctly. So what I'm gonna do is I'm gonna do a check that tests if they're on screen or not. If they're a clip routine basically. Yeah, that subdivision is actually essential for like seamless Z clipping and most importantly perspective correct texture mapping, because the PS1's GPU is actually 2D, it's not 3D. And then if you draw textured triangles as 2D triangles, they suffer from affine distortion. So that's why developers do subdivisions to hide that. The Saturn is a weird one because it doesn't really have a concept. It doesn't exactly have a concept of polygons. The quads it draws are actually just distorted sprites. It's weird. In fact, it's possible to hack up an emulator to display the polygons as sprites, and you get a really surreal view of the 3D game. So where was I? Oh yeah, I need to add a clip routine right over here. I'm gonna copy some code from existing. No wait, I'm gonna delete some dead code. This is why when you want to keep code that's not in use anymore, it's a waste of space. This one too. So we're around 700 lines worth of instructions. Yeah, early 3D hardware is quite funky. Especially on the PC side, the early 3D accelerator cards had very weird and funky ways of rendering. Sometimes crude, sometimes surprisingly precise. And then the joys of dealing with buggy drivers and getting weird graphical errors. I think you can see you can find most of them in the Vintage 3D website if you want to see what I'm talking about those early graphics cards. Like the 3D Labs Glint, there's a VESA local bus 3D accelerator, and the only one of its kind. see. You look at some other existing code, how the clip routine is done. It's actually bit field based I'm using, and is a standard technique because it's simply the fastest. Need to recall how it's being done. So there's a clip, should be an independent clip routine here. I wonder how branch labels, I don't know, how local labels are handled in a macro. So we have already constants of the clip left, clip right. Let's see, globals. Yep, I already have it. I wonder if you guys want to hear some MIDI. This silence gets pretty boring. Though not horrible MIDI. This computer actually has a pretty decent MIDI synth. It's nothing special, but it's better than the meme Microsoft GS wavetable, which is basically the sound canvas minus some effects. Makes it sound terrible, but even a real sound canvas doesn't sound particularly special. Does anyone know that MIDI actually sounds good if you have the right equipment or the right synths? So how do I do this? Okay, I think I'll just T0. Load the screen coordinates. Yeah. Anything's better than the GS wavetable. I don't know, it's a misconception that people have that MIDI sounds like garbage when MIDI can actually sound pretty good. Maybe if anyone's interested to listen to MIDI while I'm some good MIDIs on a good MIDI synth while I'm doing some programming, I might hook up the audio line and set up the mixer so you can hear both my voice and the music. So what to do here? No, I don't have an MT32, nor am I interested. The thing about the MT32 is it only sounds good sometimes, but it sometimes often doesn't sound very good. Only games that made very good, only a few games made very good use of the MT32. Mostly Sierra's games made very good use of the MT32. But I know of a retro musician friend who doesn't like the MT32 and prefers the MU90. The problem with the MT32 is it doesn't have general MIDI support. And then the general MIDI remaps don't sound very good most of the time. a sec. Just well, I'm not really familiar with the Saturn graphics hardware, but it's weird still. I don't know. Maybe Digital Foundry was a bit misleading about how the polygons are actually sprites being distorted in a way. But yeah, it also shows that. Oh, okay. But still, that really shows how weird the Saturn architecture is. It shows that as if it was originally a 2D powerhouse, and then they just slapped 3D features on in the last minute. They didn't even consider triangles. Interestingly, NVIDIA's NV1 is almost similar to the Saturn's graphics processor. The NV1 also that only draws quads. So for the first check, what operator should be BGE? Oh yeah, okay. B0 and no clip. This one. Oh yeah, I need to grab the clip coordinates. Okay. Oh yeah, I need to fetch the clip coordinates. It's in the globals, so I need to fetch an address from that. I'm thinking which registers are free. Perhaps I could just do it one at a time. So LWT1 load address V1 and V0 SG global values SC global clip XY0. Then V0. Don't need to worry about T1 is going to contain the. Oh, I'm doing X checks here. Make it like that. So X clip test. I'm gonna use V1 to contain the. Anyway, X clip test V0 T016 SRA that extracts the well, X coordinates first, so I'm going to form so T1 is the left side. V0 will be where results will be stored at. No, T3. So if this, I don't know, it's hard to explain, but basically what I need to do is when the points of the triangle are outside, it like assembles some kind of a bit array. And yeah, I see. I guess that makes sense why they made the NV1 quads only. The NV1 is weird though, because not only is it a 3D accelerator that draws only quads, but it was also a sound card and a controller, a gamepad controller, so you could like plug Saturn pads onto your PC. So in this case, I would have T3 clip left. Yeah, that's why I think, but T0 div stack SXY. I'm a little quiet at the moment because I'm concentrating. Sorry about that. It's likely that it's using the center average of the quad to put the sprite on. Next one, clip test. What do you think, guys? Should I play some MIDI? Keep you guys entertained from the silence. Also, how's my microphone audio? Does it sound correct or it's all garbled and out of pitch? Because that happened one time in my last stream. Next to clip test. SXY82 T50. Okay, looks like this part is done. So now we need the top and bottom. See if it'll assemble properly. Nice SC Global. In this case, I don't really have to worry much about reading the screen space coordinates from a div stack, because the div stack is stored in the 1 kilobyte, I think 4 kilobyte scratchpad memory area. Because the thing about the scratchpad memory is it's very high speed memory space. It takes 1 cycle to read a 4-byte word from it. It's really fast, so I don't have to worry too much about loading values from it. High-speed polygon subdividers often used it. I use it frequently. Extensively actually. That's for Y. might try to look into Saturn documentation if I really want to, even though I cannot really develop for Saturn since I don't have a real Saturn. And I think the facilities for executing Saturn programs on a real Saturn is limited. Like there's no, I'm not sure if there's an Explorer FX equivalent for the Saturn or Kaitla. So no clip Y1, 2. Okay, see ya. Thanks for joining the stream anyway. I'm not sure if I'll be doing an art stream at this time. Kinda feel like I'd rather just not. I draw but not stream it. And chances are I might get annoyed by the fact that the Wacom driver would crash again. Maybe I will. And then if it crashes I'll just not stream it. Not do an art stream. Okay, let's reset this one. Load and set a breakpoint. And step by step through the instructions, see if it's working properly. Okay, let's run if it breaks anything. Nope, doesn't look like it's breaking anything. No clipping yet because I haven't added arithmetic for that. I'm gonna look at my SMD renderer for that logic. Okay, stop again, reboot. Then we're gonna add that logic that will make the magic of this work. I'll be in here. So here it is. Basically what I want to do is do these branches. It's hard for me to explain it, but basically do AND operations between each vertex, V0 and V1, V1 and V2, V2 and V0, because these set specific bits on the state of the vertex. That it'll set a bit for clip left, clip right, clip top, clip bottom, and then somehow this technique would work. This technique here would work really well at clipping, and it's very fast too. Also, the reason why I didn't bother making these calculations function is because of speed. I want to minimize JAL calls. It's actually faster that way than jumping to a function. Plus, you need to take up some stack for the return address. I'm not sure why I think you're referring to the XA ADPCM compressed audio, which is at around 37.8 kilohertz instead of 44.1. I don't know the reason why. Perhaps it might have something to do with the fact that it's compressed ADPCM and it's on a CD that's running at 2x. Redbook audio on the PS1 is usually played at 1x speed. So I guess the reason why it's 37.8. I don't know. The thing about the PS1 when it plays XA audio is that it actually plays 8 XA channels at once, but you can only listen to one channel at a time. There might be a reason why they cannot make it so that the ADPCM audio will be 44 kilohertz. I don't know. I'm not a PS1 engineer, but that could be the likely that could be the likely reason why. Okay. Oh wait, I need to rename the registers. T3, T4, T4, T5, T5, T3. And then reload and execute. Let's see if it now clips. Well, it's not accurate, not as polygon accurate as the quad ones, but it's faster. I think it's doing some premature clipping. Well, I'm not sure. I don't have any lines of where the clip box is. So I think I'll go and put some code to draw a box around the clip area, or maybe just set it full screen and see if there's any premature clipping. It doesn't have to clip very accurately. I just want it to clip. It's actually it's actually okay to just clip chunks rather than clip triangle each individual triangle off. It's not really important. And you know this is PS1. Speed is more important. It's kind of like how N64 developers made their own microcodes that are faster than the stock one. Less accurate but more stable. It looks fine. Possible that those premature clips are... No, it's just the quads. Premature clips are usually Z-clip. Okay, CSCH. Thanks for watching the stream though. So, reboot and let me double check that I'm reading the values from the correct stock order. I'm reminded that the... No wait, it should be correct. I don't think I made it that way. Let me look at the global functions. Set clip rect. Let me see, when I set a breakpoint there. Load and execute. So it's correct, the order is correct. And let me change the clip region. I need to fix something. Oops. And it looks like it's not working correctly. Should be clipping chunks. The clip window even smaller. Mm. Screen yes and screen Y res. Oops. Oops, I forgot to reset. There's some logic tech faults here. Seems really cool and satisfying though to see all these polygons being clipped, and it's still very fast. I'm gonna sacrifice. Oh, that one seems to be working correctly. No, that's the quad. This one seems. It fails when there's 2 points exceeding certain points. This one here. It prematurely clips, so I must have misnamed the register somewhere. Okay, time to look at the source code. It's most notable on the bottom. And then I just realized the time here is a bit late. There you go. Thinking T3, T4, T5. Let me look at my old code. debug. Seems to be working correctly, supposed to be. Should be working properly, but not. Let me step on the line. Getting a little exhausted. Need to stretch once in a while. For some reason I'm also kind of sleepy. So. Ah, I found the problem. Wait. I think I did find the problem. I think it's this one. It's supposed to only SRA to 16 because the Y coordinates over here. This one is X, but it got the Y instead. No, it got the X instead. So stop and let's track that down here and fix it. Squish the bug. So yeah, it's over here. Should be that. There, the power of a debugger makes things a hell of a lot easier. without going insane. Reload. Okay. Now it should work properly. Nah. Oh, breakpoint. Okay, run. See if it clips properly. I think I have to change the color of the box to red, purple to make it easier to see. Just to make sure. So that should do the trick. It's not clipping in the top for some reason. Sometimes it refuses to clip on the top. Oh yeah, it's because on subdivided doesn't do clipping yet. It looks like it's functioning properly now. It's not exact, but it's enough to not make sure that they don't get drawn off screen. Too many. Yep, the clips are working. Now to make unsubdivided clip should be not too difficult. What if I put this in a macro? If local labels are allowed for macros. Oh, it actually worked. Okay, now let's see if it still works. So, stop, reboot. It does not clip and it's not subdivided. Doesn't have to be triangle accurate in its clipping, as long as it's fast. I think many fast custom subdividers also went that way as well. So, okay, I'll just use a clip test macro. Oh wait, I have to modify this. I'll make another one. I'll just make it keep it as a macro anyway to make things easier to work with. Clip test GTE means it gets coordinates from the GTE rather than the memory, like the div stat. So x0 it should be MFC2. MFC2 stands for move from call processor to okay, clip test GTE. It'll be before the oh, hi Maka. Thanks for coming over to stream. Anyway, I'm just working on adding some triangle clip routines. In hardcore MIPS assembly. Though I've already pretty much got the hang of it, more or less, at this point. Okay, how big is the object file? I'm curious. By the way, anyone who buys games from Steam, and does anyone find it annoying when you buy the soundtracks? They're in MP3 format rather than FLAC. Anyone here watching get bothered by that? Because I'm considering getting the Hat in Time soundtrack, but I don't know if it's in FLAC or MP3 format. I prefer FLAC. I don't understand why they didn't even point that out, as that would have been a selling point to some if the soundtrack was in FLAC format. Wrong directory. So it's in source, and then there should be like object files, subdiv f3. There it is. 6.95 kilobytes, but I think that'll be like 4 kilobytes. In instructions, I think it's just mostly symbol stuff, like for the debugger. Reload and execute. Okay, it's not clipping. I see premature. Premature junk. Another typo somewhere. Clip test GTE. Yeah, I must have missed changing a value somewhere. Yep, here it is. And then that one too. That one as well. So many typos. Okay, recompile. Reload. Execute. Should work flawlessly now. Now that looks pretty nice. Not as smooth as the quad clip, but at least it's faster. Speed, mate. Full speed, mate. I think I improved the performance too. Yep, performance is improved. It's now running consistent 60 frames per second. Well, more consistently at least. So, okay, I'm gonna go and I'm not sure what else to do. Okay, I'm gonna remove the screen clip. I'm considering. I think I should do like announcements when I'm about to stream a few days prior, but I don't know what's the best way to do it on YouTube. Cannot do like one of those posts that the accomplished YouTubers can do. I don't even know if it can own those kinds of blog style posts on YouTube are only accessible to those who are of a certain subscriber number, subscriber count. Like you have to have this many subscribers in order to be able to post blog style. Yeah, I learned programming more or less by myself. I started programming with Microsoft QBasic in 2008 when I was still in grade school. And then when I got tired, and then I switched to QB64, which was like a fan maintained successor to QB4, Quick Basic 4.5. And then I actually made some pretty interesting stuff in QB64, but eventually I quit that language. But during my last year of using QB64, I was starting to switch over to C++, so I could like make PS1 stuff, and then also be able to use make better Windows applications. Because the problem with QB64 was that it's actually very bloated. So it had to come with a bunch of DLLs that are like tens of megabytes big, and then the libraries that you can link to your program in QB64 were limited. So I eventually switched to C++, and I don't regret it. It's so much better to stick to an industry standard language. Okay, let's see if seems to look smooth. The only problems now are just the seams, but there shouldn't be any big problem. There are no triangles here, they're all quads here. And the quads are slower because the routine is just not well optimized. Though the triangle seems to sort much better than the quad. Look at the shadow, there's barely any sort problems. On the quad you can see like gaps, streaks. Yeah. It's also because the education, it's also because I learned programming too early that my computer classes don't even teach programming yet. Or at least in the schools that I've been to. I know there are schools where they're teaching programming to grade schoolers and grade school and junior high. So yeah, well, it seems my new subdivision routine is pretty much ballin' now. And I think with the seam fillers, I don't think they need any. I can just take care of that later. I've already been streaming for 2 hours and I want to do something else. I'm feeling quite exhausted, but at least I made some considerable work with my project. I'm gonna make a texture map work on a texture map version of the subdivider. I also need to update this test map to feature textured environments. And then I'll modify and then I'll use the same logic principle on this new subdivider for the quads so that it'll be fast too. So yeah, I think I'm good with this stream now. A good 2 minutes and almost 30 minutes. I don't know, 2 hours and 30 minutes. So yeah, whoever's left watching this stream, I hope you enjoyed it, and I'm glad you joined in with me. So yeah, I think I've had enough work for today, and I want to do something else for the meantime. So yeah, thanks for watching, and LameGuy64 is signing out, and have a good day.